Hello, class. Today we're going to work on 6.3 notes, performing function operations and composition. First, we're going to look at what x can and can't be, which is the domain of a function. So when you do this, you want to think about, is there any numbers that x cannot be? So for the first function, f of x equals 3x plus 5, think to yourself, is there any number that you cannot plug in for x? Well, positive numbers will work. 0 will work, and so will negative numbers. So since any number is okay, x can be any real number. So this represents x as an element of all real numbers. It just says that x can be any number. For the next function, we have 2 divided by x plus 3. Well, when you have a fraction, the bottom cannot be equal to 0. Okay, so what that means is x plus 3, whatever you plug in for x, can't equal 0. If you solve for that, that means that x cannot be negative 3. So for your domain, you would write that x cannot be negative 3. For f of x equals the square root of x, when we're square rooting a number, we can square root 0 and we can square root positive numbers, and it will give you a real answer. However, we cannot square root a negative number, so x cannot be negative. So x has to be greater than or equal to 0. Now let's go ahead and move on to looking at operations on functions. So in this first example, we have that f of x equals 5x to the 1/3 and g of x equals negative 11x to the 1/3. They want us to find the following and give a domain. So for part A, we have f of x plus g of x. So we're going to replace f of x with what it equals and g of x with what it equals first. So I'm replacing f of x with 5x to the 1/3 plus g of x is negative 11x to the 1/3. So we have 5x to the 1/3 minus 11x to the 1/3. Notice these are like terms because they both have x to the 1/3. So we're going to subtract those coefficients, 5 minus 11, to get negative 6x to the 1/3. Now, when we look at the domain, we first look at the functions, the original functions. So f of x and g of x. Notice for f of x, x is to the 1/3. So that means it's like the cubed root of x. X is also to the 1/3 for g of x. Well, when you're taking the cubed root of a value, you can take the cubed root of a 0, you can take the cubed root of a positive number, and you can take the cubed root of a negative number. So there's no restrictions on what x can be. X can be anything. When you combine them, you get negative 6x to the 1/3. The x is still to a 1/3, which is a cubed root, so there's still no restrictions. So x can be all real numbers for the domain. For the next one, f of x minus g of x, we're going to take 5x to the 1/3 minus negative 11x to the 1/3. Those double negatives become a positive, so 5x to the 1/3 plus 11x to the 1/3. So we get 16x to the 1/3. So this is as simplified as it can go. Now looking at the domain, we already discussed how for the original functions, there's no restrictions. Looking at the final answer we get here, 16x to the 1/3, is the cubed root of x. The cubed root of x has no restrictions because it can be positive, negative, or 0. So it's x is an element of all real numbers, and that's our domain. So that'd be it for that problem. All right, for number 2, let f of x equal 8x and g of x equal 2x to the 5/6. Perform the indicated operation and then give the domain. So for part A, we're doing f of x times g of x. So I'm taking 8x times 2x to the 5/6. Well, I'm going to multiply the 8 times the 2 first to get 16. And we have the x times the x to the 5/6. So x to the first times x to the 5/6. If we're multiplying them, we need to add those exponents. So it'd be 16 to the x, 16 times x to the 1 plus 5 6. So 16 times x to the 6 6 plus 5 6. So I got common denominators, which means I get 16x to the 11 6. And that would be our final answer. For domain, looking at the original problems, for f of x equals 8x, your domain is all real numbers. There's no restrictions. For 2x to the 5 6, that means we're taking the 6th root of x and going to the 5th power. Well, 6th root, whenever you have an even root like that, you can't find it of negative numbers, so x has to be greater than or equal to 0. Okay. So then looking at the last one, our final answer, we had 16x to the 11 sixth. Notice that denominator is 6, which means we're still at the 6th root. Okay, and so our domain is going to be x is greater than or equal to 0. You cannot use those negative numbers when you have an even root. So you want to take into consideration the original functions and their domains, as well as your final function, and when you look at the domain of that final one. For part B, we're doing f of x divided by g of x. So we have 8x divided by 2x to the 5 6. 8 divided by 2 is 4. And then for the exponents, we would subtract them when we're dividing. So x to the 1 minus 5 6. I'm going to do common denominators. So it's 4x to the 6th 6th minus 5 6. So our final answer is 4x to the 1 6th. When we're looking at domain for this answer, it's a 6th root again. And considering the original problems in their domains, our domain for this is going to be x is greater than or equal to 0 as well. For number 3, it says let f of x equal 3x minus 2 and g of x equal x plus 3. Find g of x minus f of x. So we're going to take g of x, x plus 3, and we're subtracting the entire f of x function. So I'm going to use parentheses and put in the parentheses 3x minus 2. I'm putting it in parentheses because that's subtraction. We have to distribute across that entire function. So what we have is x plus 3 minus 3x plus 2. So then when we simplify, x minus 3x is negative 2x, and 3 plus 2 is 5. So our final answer is negative 2x plus 5. For number 4, it says let f of x equal x plus 3 and g of x equal x squared. Find f of x times g of x. So we're going to take f of x, which is x plus 3, and we're multiplying it by x squared. So to do this, we'll want to go ahead and distribute that x squared. So we get x cubed plus 3x squared. And that's it. Now we're going to look at something called function composition. So function composition uses some new symbols. So here, this dot, when you do h of g of x, that indicates it's a function, not multiplication. So if it's an open dot like that, it does not mean multiply, okay? And like it shows here, another way of writing a composition is h of g of x. So that's, notice how you read it, h, then you say of g of x, okay? Now, what we're doing here is we're taking the function h and we're replacing x with what g of x equals. That's what it's doing. So you're replacing x in one function with the value of the other function. So let's take a look at some problems like this. For number 5, it says let f of x equal 3x minus 4 and g of x equal x squared minus 1. What is the value of f of g of negative 3? So like we do in order of operations, we're going to start on the innermost here. I'm going to take a look at g of negative 3 first. So I'm going to go ahead and find g of negative 3. So what that means is in the function g, I'm going to replace all the x's with negative 3. So I get negative 3 squared minus 1. Negative 3 squared is 9, and 9 minus 1 is 8. So that was g of negative 3. Now looking at this composition, what it's telling us is that in the function f, we're going to replace x with what we got for g of negative 3. So I'm going to use f of x but now it's f of what we got for g of negative 3. So I'm replacing that x with what we got, which is 8. So it'd be 3 times 8 minus 4, 24 minus 4, which is 20. So f of g of negative 3 is 20. And that's it. Now we'll take a look at a few more. For number 6, it says let f of x equal 6x to the negative 2 and g of x equal 4x plus 5. Find the following and give the domain of each composition. So for this first one, we're finding f of g of x. So what that means is we're going to take the function f, which is 6x to the negative 2, and we're going to replace the x with what g of x equals. So when I do this, I'm going to start with f. So f is the 6 times x to the negative 2. So I'm going to put the 6 down. But I'm replacing the x with what g of x equals, 4x plus 5. And that's going to be to the negative 2. Now we're going to simplify it. I have a negative exponent, so I'm going to move that part downstairs. 6 over 4x plus 5 squared. So for 4x plus 5 squared, it means 4x plus 5 times 4x plus 5. So we would multiply that out. 16x squared plus 40x plus 25 would be your simplified version of foiling the denominator. So we have 6 over 16x squared plus 40x plus 25. That is our composition. Okay. So now we need to find the domain. So looking at the bottom, we're trying to think of what x can't be. When you're doing this with a quadratic like this, it's easiest to figure out what the domain can't be by looking at the factored version here. Okay, so looking at that factored version, we know that 4x plus 5 can't equal 0 because then the bottom would end up being 0. So on the side here, I'm going to figure out if 4x minus 5 can't be 0, then x cannot be 5/4. Okay, so x can't be 5/4 is part. Okay, so now let's take a look at part B, g of f of x. So we're going to start with function g, and we're going to replace x with what f of x equals. So if we're starting with g, I'm going to put down the 4, and then I'm replacing the x with 6x to the negative 2, and then I'm going to put the plus 5. So when I multiply this, 4 times 6 is 24, times x to the negative 2 plus 5. I don't want a negative exponent, so I'm going to move that downstairs. So it's 24 over x squared plus 5. So that's our simplified version of the composition. We have to look at the domain. For the domain, think about what x cannot be. Since we have x squared in the bottom, it can't be 0. So for a domain, x is all real numbers except x cannot be 0. For part C, we're doing g of x. So we're taking g of x and we're replacing x with what g of x equals. So starting with that g function, I put the 4 down. Then I'm going to replace the x with g of x. So I'm going to write 4x plus 5, and then I'll put the other plus 5. Now I'm going to distribute that 4, so I get 16x plus 20 plus 5. So I get 16x plus 25 as my simplified version of the function. Now this function doesn't have any restrictions because x is not in a root, x is not in the denominator of a fraction. We can multiply 16 and 4 by any number. So our domain is all real numbers. Okay, for number 7, it says if g of x equals 4x and h of x equals the square root of x, find h of g of x and give the domain of the composition. So we're finding h of g of x, because remember that's not multiplied, that's composition. So I'm going to take the function h, which is the square root of x, but I'm replacing x with g of x, which is 4x. So I have the square root of 4x. Well, I know the square root of 4. I don't know the square root of x. The square root of 4 is 2, so I get 2 root x as my composition. For the domain, when you have the square root of x, you can't find the square root of a negative number. So x has to be greater than or equal to 0 for your domain. And that's it for number 7. For number 8, it says if f equals 5x and g equals x divided by 5, find g of f of x. So for g of f of x, I'm going to start with g, which is x over 5. So I'm going to put over 5, but I'm replacing x with f. So I'm going to replace x with 5x. When I simplify that, the 5's cancel out. So g of f of x just equals x. For f of g of x, which is part b, I'm going to start with f. So I'm going to put the 5 down, but I'm replacing the x with x over 5. Put the 5 over 1. You can either multiply straight across and then divide, or you can see that these cross cancel, so you just get x. And that is it for notes today. If you have any questions, be sure to contact your teacher.